Happy Halloween and welcome to Rise's Spooktacular Knowledge Share on the pentagram of LLM Observability. I'm Amber, an ML growth lead here at Arise, and I'm going to talk to you about these 5 points that emphasize the need for LLM observability. These 5 points are the evaluation, traces and spans, prompt engineering, fine-tuning, and search and retrieval that go into building LLM application systems. We're going to dive into each one of these individually, but if you want more information, check out our free courses on these topics. For growing e-commerce use cases like chat to purchase, we know how users interact with the large language model and eventually end up getting a response to their question based on the information they provide. But what a lot of people don't see under the hood, unless you're working with large language models, is that step with the structured extraction, the ranking, and recommendation model. And even breaking it down further into areas of LLM observability, you have to monitor troubleshooting for agents and chains, and for spans and span types. You have to monitor for your prompt template based on the prompt engineering that you have done and the prompt templates that may or may not need switched out, ranking model metrics, search and retrieval troubleshooting, and then user feedback and LLM assisted evaluations. So all of these go into the area of LLM observability and what we're going to be focusing on in this knowledge share. So starting with search and retrieval, the way search and retrieval works is first you have a collected knowledge base of information. This might be stored in a vector database, for example. If your user asks a query, that query is turned into an embedding. That embedding is then used to look up similar documents to see which ones are in a similar latent space. That document chunk has its own embedding, and once you find the most similar document chunks and documents that are responsible for answering that query, through a prompt and through an LLM, you could generate a response back for your user. And all these are wrapped in traces and spans for a known callback system. So if you're interacting with your selected large language model, every time you invoke it, it's documented in a callback system via trace. So this is an example of one trace where each span is referred to a unit of execution. The most common span types that we're seeing are around large language models, chains, tools, agents, embeddings, retriever, which that can retrieve information from any database, and re-ranker, which is now being used more often as a relevance-based reordering of documents. Going back to a chatbot example, every time the user interacts with that chatbot, every time that pieces of that conversation are happening, traces are produced that you can look at the individual span types, and you might see how this is going to be related to using LLMs for troubleshooting. Next, looking at prompt engineering. We recommend prompt engineering as the first method to tuning your large language models. Every time you're interacting with a large language model where you don't have the proprietary information, it's mostly acting as a black box, what you can do to best append that large language model for your use case and tasks is with prompt engineering and creating prompt templates to be used for testing. So here's an example of testing out different prompt templates. I also highly recommend checking out Arise's prompt playground, which launched in the Arise platform. Now, we do have a free version of the Arise platform, and you can play around with the prompt playground. You have information on the original template, the original response, the new template. You can change out variables like the temperature, the large language model being leveraged, and all the variables that go into the construction of that prompt. So it's very fun. Highly recommend you play around with it if you want to see how your prompt can be changed to generate better responses in production. Next, let's look at fine-tuning. Now, fine-tuning these large language models is not very easy, and we do recommend you look at fine-tuning after trying prompt engineering, after providing relevant information through search and retrieval, because while you can export new data, do types of fine-tuning, even tune open source large language models, it has been shown that the easiest way to increase performance for your large language models is first doing prompt engineering, but it can be very valuable, and we've seen fine-tuning accomplish a lot in the LLM space. Next, evaluations. So evaluation metrics for LLM really focus around LLM assisted evaluations, user provided feedback, and task-based metrics. So we recommend as many of these as you can leverage. Most teams want to try collect as much user feedback as possible. So a thumbs up, thumbs down. Is this relevant or not relevant to what you have been going through, especially with chatbots? Task-based metric for your specific use case. And LLM-assisted evaluation is becoming more popular with leveraging a different LLM for the evaluation step than the creation step. And having a human in the loop is always preferable in these use cases because LLMs are prone to hallucinations. There's also a major difference between using large language model evaluations and using large language model system evaluations. Now, the difference here is going to be looking at LLM model evals where you have a prompt template, you have a model tested, and you have the output. So changing out the different models tested to see how that affects the output until you know which large language model you're most comfortable using. Now, you can't change the actual large language model too much because most of those are proprietary, but you can experiment with the input data with different data sets and see what the response is. Similarly, once you decide which large language model you want to leverage, you can look at LLM system evaluations. This is what machine learning engineers are more commonly doing if they're not researchers. They're most likely selecting a model based on their use case, based on what research is saying, this LLM is best equipped for. And then they're changing out the prompt templates and doing prompt engineering to generate best responses. And it's always good to have a prompt library to change out different prompts and make everything as relevant as possible. Some of the fundamentals for working with large language models in production, you want to be able to first benchmark with what we would call a golden data set, where it may take a while to curate such a data set, but the ground truths are in, they are correct, they've been vetted, and it's an ideal data set for the benchmarking task. Also using evals for task-based metrics, so looking at templates, we talked about evaluation templates, and then having data set combinations define your performance. These evaluations need to run across a variety of environments, so notebooks, application systems, APIs, and they need to be low latency, high throughput systems. So tying it all together, when you're interacting with a large language model or your user is interacting with your LLM application system, every time the LLM is invoked, you get a trace that has a series of spans which correspond to the steps in that LLM pipeline. And then you can look at the individual spans based on search and retrieval, based on prompt engineering. You can change out the prompts for the individual spans because you're going to have prompts for your agent, for your tool, for your large language model, for the document selected, for the output that you're sending back to that user. So all those prompts can be visualized, they can be edited, and you can also see the individual documents that had been chosen for that response if that response isn't ideal. We like using our open source solution Phoenix as a Phoenix library for eval templates, for model parameters, and for evaluating our large language models. So once you have that information and you add in your evaluation metrics like relevant, irrelevant, if you want to add in metadata or user feedback, you can do so as well. And then you can begin to troubleshoot these large language models in production. Anytime you're giving a user a non-optimal response, that is captured and the trace for that response is captured. So you can go into each step and troubleshoot it. You can also start troubleshooting based on latency, based on token count, and other parameters that make up the system of an LLM application.